Hello everyone, thank you for coming. I know it's late, so everybody is tired already. Welcome to my presentation entitled Embracing Clean Architecture and Spring Boot with Kotlin. So as it's not hard to guess, we're gonna talk about architecture and what is the clean architecture actually. And in my presentation, I'm going to go with some theory and go through some architectural styles to see the differences and advantages and disadvantages. And then I've prepared some case studies, so we will build some very basic example of application, choose very basic architecture, add some complexity, and try to refactor it toward clean architecture. Okay, so before we start, a few words about myself. I'm senior software engineer at Stepwise. I've been programming in Kotlin for 6 years right now. That's why I call myself Kotlin passionate, because I really enjoy it. And also JDD enthusiast, because I'm very passionate about any methodology that helps us deliver more suitable software for the business perspective. If you'd like to catch me on some social media, feel free to do it. Especially, I'd like to invite you to my Medium account, where I post articles from time to time. So recently, I've posted about null safety. So just question for you guys: who's programming in Kotlin? Okay, who's programming in Java? Okay, yeah. So that's something very hot topic when it comes to the Kotlin versus Java preferences, and I know that many people has different opinion on that. So. Yeah, if you'd like to read it, I invite you. Let's talk about architecture. So the question is, what is software architecture? I asked ChatGPT to generate some image, how AI sees the software architecture, and this is it. I don't know, maybe what this laptop is doing here, but basically it's some kind of organizing stuff. So we might think about software architecture, and we probably think about it as organizing some stuff, setting boundaries, setting contracts between the stuff we want to organize, and that's basically it, right? When we think about architecture, it's maybe good to start with this metaphor, because it comes from the civil engineering. And in civil engineering, we have the architect who is creating a blueprint. And the blueprint is kind of an instruction for anyone who is involved in the project, actually, sorry, how to build it. So that's basically what we want at the start of the project, a plan, how to do it. And so anyone who is on board knows what to do, how to do, and we can estimate it, and it's pretty easy when we take a look at this. So this metaphor might be, a good fit here, right? Because it's basically the same. But when the building is done, when it's built, and we'd like to change something, it's of course possible to replace windows with, I don't know, put the wall there, or repaint the walls, but it might be not possible in all cases to replace the basement, let's say, and in software engineering, that's the case. We sometimes want to replace the basement. So this leads us to software engineering, which is kind of different to civil engineering, bless you. And when it comes to the software engineering, it's not like we have a plan, nothing changes. The only constant is change in the software engineering in any project. And that's why when we think about software architecture, we might want to think about it as something as a result of the decision that we made in the project. It's not basically organizing the code. It's actually something very, higher level of organization stuff. Something that we made some decision we might regret in the future. And people asked about what they think about architecture. What is architecture to them? Usually say that architecture is about the decision they wish they had made at the beginning of the project. So this leads us to the second definition that I really like, that architecture is about the important stuff. And each project is different, so the important stuff there is different. And that's why if you're looking for a holy grail, a single, universal, good fit for any project architecture, it doesn't exist, because it's about, fitting to the particular problem. So what drives our decision? Architectural drivers. So when we make a decision at some point in our project, because some business requirement has changed, and we need to make a decision, it's driven by some stuff. That stuff can be segregated into 4 categories, let's say. Functional requirements, so what we're gonna build, how it's gonna behave. Quality attributes, so how performant does it need to be, and how maintainable does it need to be in the future. So that's scalability, let's say. Technical constraints, like we have a team, there are people that they have some level of experience at some particular technology. So we cannot say to Java developers, hey, let's write this in Python and expect them to do it as good as in Java, okay? And business constraints like deadlines, law regulations, budget, stuff like that. So when we have all that stuff combined together, and we know that some decision was made because of something, we know that it's some kind of a trade-off, and these trade-offs actually structure our architecture. Just to give some example, let's say that we have some base level of functionality, performance, maintainability, and readability in the system. Let's say it's after sprint 1, and business comes to us and say, hey, we need a new function. So we implement it, and apparently the performance dropped. We have more functionality, but performance dropped. And business is, of course, not happy about it, and they want this particular method that was, let's say, latency was 3 seconds, now it's 5 seconds, and they say it's not acceptable. So what we do the research. Let's say that there's some kind of a tool, library we don't use, but we can learn it, and we can use it. But to learn it, we need some time, let's say a week or 2, and there's a problem also. Ah, yeah, it's okay, sorry. There's a problem because there's a hard deadline. And by hard deadline, I don't mean that somebody has, you know, opinion that the deadline is not easy to postpone and it cannot be done. There are deadlines like Black Fridays. You cannot say, okay, we will do Black Sunday. No, that's not how it works. Let's say that there's an audit and we cannot, you know, say to the auditors, we will be late 2 days and let's come to the next week and meet together. So basically, in scenario like this, what we do, we have 2 constraints. We have constraint team's experience and hard deadline. So what we do, ugly optimization. And it can be, I don't know, having this method put into the database layer and made some optimization there. It's very ugly, and that's why, let's say, okay, our performance is back, but the maintainability and readability dropped. And that's okay. I mean, we know what are the constraints, and if you write this down and business is aware of what the trade-off was made, and anyone on the team knows that, then it's totally okay. Because basically, architecture is about trade-offs. And that's what I wanted to point out at the very beginning, because usually we like to use some fancy new architecture, new pattern that we'd like to try in our project, but that's not the case. We should use the tools where are needed. And to go forward towards our demo, let's talk briefly about most common architecture styles. So the very basic one, layered architecture. So we have usually 3 layers which are responsible for different type of stuff. Usually it's presentation, business, persistence, right? And it's just simple. Everyone knows how to do it. In some examples, in some very basic applications like CRUD, when we do just create, read, update, delete, nothing else, that's just enough. Of course, we can have 2 layers, not 3 layers, but 2 layers, in example in which we don't have any business logic. So why should we, you know, use the business layer if it's not needed at all? And of course, 3 layers is not the maximum. We can have as many layers if we'd like to. And the clue here in this architecture is that we have the flow that comes from the top to the down. So that's basically what layered architecture is about. If we'd like to fix the disadvantages of the layered architecture, which is tightly coupling between layers, the complexity which is added triggers the maintainability dropping down, right? So there's onion architecture you might be familiar with. In onion architecture, we'd like to have a domain-centric system. That means that in the domain, we'd like to isolate anything that is the most important in our application, in our project. In domain, we have our domain model, domain services, etc. And domain doesn't know anything about application, about presentation, about persistence, message brokers, stuff like that. Then we have application, because in some cases, domain is not enough to express some complicated business processes. When you're familiar with domain-driven designs, you know that there are aggregates which are kind of, let's say, the lowest level of separation between stuff when we do architectures like this. So when we have something that operates on more than one aggregate, and it's just going through the boundaries between aggregates, we'd like to put it in some organized higher process. That's why we have application layer for some more complex processes. And in the presentation, infrastructure, persistence, this outer layer is for all ugly stuff. We put it there. That's why we have testable system, because domain doesn't care about stuff that is not important. Everything is separated well. It's well testable, and it's flexible, because we can just replace anything that is in the outer layer. And I'd like to make a distinction here, because many people mix these two architectural styles, hexagonal and onion, because they are very often mixed together in a hybrid. Because hexagonal might look very similar to the onion one, but the key here, the clue here, is that we have port adapter design pattern implemented. And that's because we like our core to be independent from all that stuff that is ugly, that is breaking our rules. Let's say we have database integration, we use Hibernate, and Hibernate doesn't like Kotlin's nullability, and that's not what we like to have in our domain model, right? But as you can see here, core is just core. We don't need to have any layer there, because that's the clue of hexagonal architecture. And I know pros and cons are still the same, because basically we can achieve pretty same advantages, and we also take disadvantages as well. So basically, when it comes to the disadvantages, it's more complex, as you can see. So there's a learning curve. If you give hexagonal or onion architecture to some junior, it might not be very intuitive at the very first moment for them. And more boilerplate code, right? So the question is, what is clean architecture then? Is a book, thank you. No, I mean, it's a book. You can read it, I totally recommend it, but in this book you can read about different methodologies, different tools that helps you achieve the clean architecture, which is actually a way of such an architecture that is good enough for that particular problem. And that's why when we think about clean architecture, we can think about it as some kind of a hybrid, because we can use hexagonal there, we can mix it with onion, and that's why I usually see this in your project. And of course, if there's a use case for not using such fancy architecture, we can use simple two-layered architecture for some, I don't know, projection over the database or something like this, right? So let's say that we have such an example of clean architecture. So we have basically an onion architecture with dependency inversion implemented with port adapter pattern. So that's how we make the flow domain-centric here. And that's what we're gonna achieve starting in our demo, but we're starting with some very, very basic example. So let's take a look. It's gonna be very simple application, right? We'd like to have capability to add product and to have product listing. So basically two endpoints, right? Nothing complex, and how I see this is simple three-layered architecture. We're gonna add some complexity later. And yeah, that's the time for the demo. I mean, I will just show you how it's gonna look like when we just see the code. Let me do this. Okay, so basically we have controller, right? Some simple post mapping here, get mapping, nothing complicated here. Service, which is simple service calling repository, of course transactionals here from the Spring. And as you can see, repository is a simple JPA repository using model, which is actually the same model for JPA, and the business logic. That's what I've seen in some projects, and you probably also have seen it, and that's something that people start with when doing that kind of architecture. So that's why I wanted to present it this way. And yeah, so that's it, nothing complicated, right? Let's now add more complexity. So what we'd like to have is to add discounts to products. And there will be two types of discounts. There will be discount like you know from all kind of food delivery application, buy 2 for 1, something like this, and for the price of 1, and count-based percentage. So basically, if you meet a threshold, like buying 100 pairs of socks, you will get, I don't know, 5% discount, right? Something like this. And for the purpose of the presentation, I don't want to introduce order in this very simple demo. That's why, as you can see here, we're gonna have two post endpoints, additional two post endpoints, one for adding discount to product. So as you can see, product will be very strongly coupled with discounts. And for calculating the price, we cannot have some simple get endpoint, right? Because we need to know, okay, so how many these products we'd like to have in a cart that doesn't exist in our domain language yet. So that's what we're gonna do. How I see it, let's say that we'd like to follow the three-layered architecture because that's something we already have. Why should we refactor it? It's working, right? So that's what we like to do. We still have three-layered architecture. We have right now additional discount service, which will be, let's say, extracted here because, yeah, product is for managing products. Discount service will be for managing discounts. Why not? And this is it. This is what we want to achieve. And then let's talk about refactoring further. But for now, we're gonna see the code, right? So I've prepared Git commits here to check out simply, not to because we don't have that much time to make real live coding. And what do we have right now? So this is actually a very good example of the object relational mapping, because people usually say that this problem doesn't exist. I met online people who were arguing about it with me, and we just were talking about it. Yeah, so the point here is that we have discount, which is an abstract class, and as you can see, there's a lot of object-oriented programming here, right? And we can simply map it to a table using Hibernate, but I don't encourage you to do this. It's just something that we're gonna refactor later, because I don't like it either. So what do we have here? We have discount, right? And this discount is abstract class. We have some subclasses. They override this function, but it's not actually important what this code is doing right now. Just to see the structure, it doesn't change at all, because we still have API, we still have model, repository, service, stuff like that. And what I wanted to start with, maybe also I will show this service at first, because it's getting complicated here, many stuff in one place. It's kind of dirty right now, but we're gonna refactor it, right? And what should we start right now with refactoring it? That's the question, and my personal opinion here is, because what bothers me the most is actually having the same model for JPA and our domain model for our business logic. Because we have no single responsibility principle here, no separation of concerns, and it's all mixed up. And basically using Hibernate in such classes and force us to make some fields nullable or do some other dirty stuff that we don't want in our domain, not because some integration stuff needed from us, right? So what we're gonna do at first? I'd like to extract persistence as an adapter using the port adapter design pattern. So let me check out here, and yeah, let's hide it. So yeah, for the purpose of this commit and to see what happened, I extracted two catalogs here, port and adapter, to see how it's gonna be used in our project. So the port is a simple interface, and it uses, as you can see here, it uses our model. The model right now, when we take a look, it's simple Kotlin. There's no Hibernate, no annotations, no stuff like that. And it's, let's say, it's clean, okay? We have just Kotlin there. So we achieved that. That's okay. Product repository interface is used right now. Sorry, that's implementation. It's used right now in our services, so that's okay too, because we don't want them to use the actual implementation. The implementation will inject something that is dirty. In our case, it's JPA, right? Because we like to integrate using the JPA product repository. And all the stuff that is right now related to mapping from entity to entity and stuff like nullability issues, yeah, stuff like this. I don't know. I know that it's not the perfect example. It shouldn't be done this way, but throwing some custom exception. But you know, it's just a demo, and it's not the point here because we like to talk about architecture. So this is how we can do it. We extracted a repository as a port. Now we have an adapter. In adapter, we have all the dirty stuff. What we can do next? When we take a look right now in the discount service, okay, it's now less complex. I introduced here factory method, extension function actually, for creating discount. But when you have discount service and we talk about it, think about it in the way that it's our business service and there's a business logic, why do we have, let's take a look here, why do we have API in the imports? All the time, anytime you'd like to check if you have some weird dependencies, it's good to take a look at your imports. If there is API in the domain, that might be something wrong, right? So I don't like it. I don't like having DTOs here. I would prefer to have discounts and operate on domain objects. So to achieve this step, let's extract actually the domain and application as separate directories here. We won't extract them as separate Gradle modules, but yeah, it could be done too if you'd like to. Check out, yeah. So right now, what do we have is discount service having discount here. So we take discount as parameter, we return discount, and it's, yeah, much simplified later, right? It's you know, all we do is actually making small simplifications, and it's cleaning up our architecture here. And what now? When we take a look here, yeah, there is a product service. We also have our domain classes, and you might have noticed there's another service here, pricing, because I thought that, okay, we manage discounts, we manage products, so calculating price is something kind of different, so let's have it in another service, right? That's what is actually implemented here. So this is it, this is our domain. In domain we also have model, all classes like entities and value objects and some data classes for data structures we might want to use in our domain, right? And what next? When we take a look, there is an application extracted right now. And an application layer, because our example is very, very simple. And we don't have, maybe we have, but we don't have many complicated processes. That's why I introduced a use case as one of the alternatives for application, let's say, services, because you might want to use application services. I like the use cases because they actually says already what's happening here, and we like to have single use case for single use case, right? So it's better when you don't want to have big classes which have everything inside. And for our demo, calculating price seemed to be a good candidate for a use case, because basically when we calculate a price, we don't calculate it on a single product, but we have many products, right? So that's why I extracted it. I don't say it's a perfect example, but it's something that I wanted to show on the demo. And what next? What can we do next? When we take a look, yes, sorry, there's a hint, and you already probably read it there. When you take a look at the discount service, there is something that I don't like a lot, having transactional here. And yeah, maybe service also is not good here, but as service only creates the bean, register it for the Spring, transactional is actually some kind of implicit dependency to the database in our domain. So we don't have that in imports, but actually through the Spring, we have it. So that's why transactional in domain might not be a good idea if we'd like to have this clean architecture approach. Yes? Yeah, sure. We can go through the controller. In general, this repo is public, and I will share the QR code later, because I know that going through the whole code just from the architecture perspective might be, you know, not a good pace for everyone. That's why I wanted to share it, and there are also good comments. So if something is missing, you can ask, and you can also later on check it on your own and go through this. But yeah, I will show you how it's going right now. We have the controller, and right now, yeah, that might be something that you wonder about. We inject here both product service and discount service, and also this use case. The use case is also using product service and product repo for getting products, right? And let me go back. So this is it. You know, we don't have that much time, you know, to go line by line and see the flow for each of the endpoints. But yeah, to see the flow, that's basically it. The product service using the product repository, which is still a port implemented here. And here we just call the JPA product repository. There is no discount repository, as you can see here in the model for the JPA. Let me show it to you. We have entities here. We have a simple entity for discounts and products, and product entity is right now kind of managing the discounts. That way that might look like having discounts as value object, but it's a different topic because it's the JPA, not the domain-driven design. So there are different orthogonal areas, let's say. Yeah, so that's it. What I wanted to do right now, let me go back here, get rid of this transactional, right? So to do it, we can make a domain framework agnostic. So what happened here is that we have service that right now don't have this annotation here. There is no transactional here, also no transactional here. When we take a look at other services, it disappeared too. And you might ask, okay, so where is it right now? Basically, an application layer, we can have the configuration for all the beans. And there are different opinions on that, because application having the use cases, for some people might be the area that we shouldn't put framework. So if not in the application, we would put it in some layer above, or use some dependency inversion to create it somewhere, because it needs to be created somewhere. The cool here is that we can just do it anywhere using a configuration from Spring and create as beans, so they can be later on injected using a Spring Boot. So yeah, this is it. And did I forget about something? Probably not. Yeah, so yeah, let's go back here. If I forgot, we will go there later and see it. So what I wanted to show at the end, this is basically what we achieved, and maybe that's something that you wanted to see, to visualize it, asking the question about the flow. So this is it. Maybe it doesn't look like onion, maybe it doesn't look like hexagon, but we can make a circles and see where is which part of the onion architecture we try to use right now. There's a presentation, of course, user use it directly. We have persistence, which is right there. We also have application, which is here. And then the rest is domain. And the clue here is, when we take a look at the arrows, they are always coming to the domain. They never comes the other way, and that's the clue. We'd like this domain to be center, heart of our application of the project. And you might also wonder, that's very weird, right? Because why do we use domain directly from presentation? And in our case, it doesn't need to be necessary to have another service there, just to put some artificial layer, just to map it to another data structure, or just invoke a function, just to make it good with the standards. So that's my personal opinion, that if there's no need to introduce something, why should we do it, right? And that's the case. So what I wanted to show you, there are some symptoms of unclean architecture, and I'd like to summarize it and maybe put some symptoms that I didn't show in my demo, but they might be common in very different projects. Tight coupling, as we have seen, having entity for managing both stuff, business and JPA, having layers which inject directly the lower one, it's tight coupling, and it might be it might be a problem in the future when we like to increase the complexity. When you have a code which is hard to test, that means we don't know what should be mocked because we use mocking for some reason, and we have so many things to mock, we don't know how to start even writing that code. Then it's a symptom of having too many dependencies there. Mixed concerns, like the JPA with the business, right? And circular dependencies, actually I didn't have it, but whenever you have a cycle in your dependencies, that's something wrong with the project. When the project is difficult to extend, which means when we have multiple, let's say we have multiple modules, and we need to just implement a simple function somewhere, simple feature, and for some reason we need to go through half of the project, but we have modularity, yay. You know what I mean. If it's hard to just add some simple functionality because of architecture we are using, because we like to be so pure and so good with all the difficult stuff we can do with architecture, then it might be good to reconsider using some simple architectural style. When we have some very tiny change, I don't know, backfix, and we don't know where to put our change because the structure of the code is unclear, it means that something with the architecture is wrong. And I wanted also, because when I thought about this demo example I presented today, I thought about these discounts and products and their connection to each other, and I was questioning myself, is it really a good idea to present something like this? And I was questioning if, okay, so in many platforms, when we have discounts, usually people registers, and we like to give them discounts because of being a new registered user. And having coupled discounts and products makes it a little bit complicated. And then I was thinking, okay, so maybe discounts, what could go next with the discounts? So that's the question I would like to ask the business about the discounts. What will happen next? Do we want to, I don't know, schedule it, make it disable them for some reason? And then I thought, yeah, so maybe the thing I'm thinking right now about is not about the discount with products, what I already have in my legacy, let's say. Let's say that this 3-layered architecture was the legacy we have. then maybe having additional requirements like discounts campaigns and creating campaigns, activating them, deactivating them, maybe it would be a good candidate for another bounded context. I don't say it would be microservice, it could be a module, whatever, but it made me think that, okay, so the next step might not be just refactoring the whole application we have just because there is another requirement. Maybe we can reuse what we already have, add some additional endpoint for removing a discount from product, and then it might be pretty easy to achieve that. And that's something I just signed it as exercise because I thought that if there was someone who would like to, take up some exercise and maybe play around a little bit with this, that might be a good idea. Feel free to do it. And at the end, I'd like to share some additional tips because, as you can see, questioning, answering questions makes us understand the business better. That's why I'd like to encourage you to use the domain-driven design, and not only technical one, because I know that the code is the most fancy part of programming, but the earlier part, which is strategic domain-driven design, is also good enough. I mean, it's also very fancy, but it's of course harder and makes the whole project easier later if we understand the business. Architectural drivers, don't forget to write it down, make it transparent so anyone who's just joined the project know why it was done this way and won't ask any questions like why did you optimize it? It's not working well. It's just ugly SQL. Why is it here, right? Write it down. Then everything is clear and transparent, and anyone who's got a little bit of experience in projects will understand this decision, right? And don't forget about very basic stuff like case solid, dry, because these methodologies actually, if they are broken, the architecture probably is broken too, but you might don't see it yet. And last but not least, do not over-engineer, because using architecture which is not the best fit because you want just to try it, it's not a good idea at all. So yeah, that's it. Here's a QR code I told you that I will share with the repo. There are also slides if you'd like to take a look once again. And we have a few minutes for questions if you have such.